Jim Green.
Good afternoon. I want to talk today about the wonders of our solar system. And I'll put this in perspective. Humans have looked back over their accomplishments over many, many years and centuries, and they have selected enormous achievements that they have done. We all know about the 7 ancient wonders of the world, the Hanging Gardens of Babylon, the Lighthouse at Alexandria, the Pyramids of Giza, etc., etc. But today I'm going to talk about the 7 wonders of the solar system. Now, some of these will be familiar. At least you'll think they're familiar. But I'm going to talk about new discoveries that have occurred only in the last several years. And because of that, they have become new worlds of interest to us. And oh, by the way, if you think the comet encounter that we had this morning will be one of the 7, well, you'll just have to wait. For the first one, I want to talk about this planet. This is the planet Mercury. It's our smallest terrestrial planet. It is the closest one to the sun. And it is an unbelievable object. We have flown by this before in the 60s and the early 70s. Very cratered. The images looked horrible. But we've done this more recently with a spacecraft called Messenger. These are 2 images from 2 of the 3 flybys that it has done. And it's looking at Mercury with brand new sets of instruments. And these instruments are looking in the infrared. As Mercury heats up from the sun's light and emits in the infrared, we're able to detect major changes. Those changes tell us about the mineralogy on the surface. The mineralogy is all about how it is composed and how material has been brought to it, or it is gathered as it has accreted in its position in its early part of the solar system. As you can see, the colors are spectacular. In the image on the left, in the upper part of it, a huge region called Cleoris Basin. We now know, based on the mineralogy, that this is of volcanic origin. Some of the craters that have hit, that have been created from impacts of a variety of material that's hit this planet, has generated ray structures that reach halfway around the planet. But a couple things that are just absolutely striking about this. This planet is bigger than our moon, smaller than Mars. We would assume it would have a density in between the two, but Mercury is almost as dense as the Earth. What happened to it? Did it accumulate a huge amount of iron? Was it crushed? What are the conditions that made Mercury what it is today? It has a core. The core is bigger than the core of the Earth. It generates its own magnetic field. It pushes the solar wind aside, except for 2 places in the pole for which solar wind material impacts right at the top of the pole. Sputters material off. Sodium, that comes up the magnetic field and goes down the tail, along with magnesium. And if we look at Mercury in just the right way, we see these long tails of sodium and magnesium going out, streaming into the solar wind. Things that we've never seen before. Mercury is truly a new world to us now. And what matters next for Mercury? Messenger, once again, is coming around. And in March of 2011, it will ease into orbit around Mercury for 2 years and make spectacular measurements and helps solve the mysteries of why Mercury is the way it is and perhaps why other planets around other stars will look like Mercury. The second one I want to talk about. This is the Earth's moon like you've never seen it before. Now, it is the backside of the moon, and of course, we have to have a spacecraft to see it if we're going to look at the backside. But we have colored the moon from red to blue in a spectrum. The red indicates, and the white part of the red, the very highest parts of the backside of the moon. The blue indicates the very lowest parts. The difference is about 19 kilometers. And that is an enormous distance. In fact, There is a 19-kilometer distance here on the Earth if we go to the Marianas Trench, 11 kilometers deep in the ocean, and then go to the top of Mount Everest. That is a difference of 19 kilometers. The region in blue that's in the southern hemisphere, this huge region, this basin we call it, stretches from the South Pole all the way to a crater called Aiken. We call the basin South Pole Aiken Basin. The moon really took one for the Earth. Some enormous collision happened in its past that carved this region out, blew away most of its crust. The lower mantle is right there. The lower crust is right there. Perhaps the mantle is there. We cannot even get to mantle material on the Earth, and yet it may be on the backside of the moon for us to look at and understand how planets like these, our terrestrial planets and moons, are put together. The moon is truly a beautiful object and one of further study. The next one that I want to talk about is Mars. We've talked a little bit about Mars today. Mars is most Earth-like. If humans were ever to leave low Earth orbit, Mars as a destiny would be a worthy place. But when we first flew by it and we looked at it, it also looked very cratered. We thought it was more like the moon. And it took us a while to realize that Mars was much more fascinating than just cratered object, moon-like. So we put in place a program over the last 10 years to look at Mars in a rather unique way, and that was trying to find the water. We see from a distance the white polar caps. That's carbon dioxide snow. That's not H2O. But is there H2O there? Did H2O, water, exist on Mars in the past? Was it wet in the past? And could it have harbored life? If it was wet, the probability that it harbored life is great, and we would like to know that. But what we found over the last several years when we looked at Mars in many different ways is signs of past water everywhere we looked. We landed a system called Phoenix in the northern polar region. It dug down, it found a water layer, and it tasted it, and it was 99.9% pure water. The rovers, Spirit and Opportunity, find laying on the ground these little round nodules that are seen in this. We call them blueberries. Sort of what they look like describes their size. They are hematite. They're iron oxide that's made in the presence of minerals and water. We have seen what look like deltas, fast-moving water that has taken material and dumped it down, much like our deltas here in the end of the Mississippi. And most recently, from Mars Reconnaissance Orbiter, we see fresh craters being created. Fresh craters being created. Yes, Mars is bombarded just like the Earth gets bombarded, just like the moon gets bombarded. Happens all the time. And these fresh craters, as we fly over them, we see white material laying out along the edges. In about 40, 50, 60 days, as we pass over again, the white material is gone. So we've taken spectra, and the spectra is spectra of water. We have uncovered water layers, mid-latitudes on Mars, and we believe they are extensive. Our ground-penetrating radars has indicated that they may be several stories thick, and what we're looking at is perhaps a buried glacier. When Bobby Braun talked today about bringing material from Earth to sustain life, I'm sure he was thinking about vast amounts of water. And I'll tell Bobby next time, leave the water at home, bring your straw. But Mars is not done surprising us. We have looked over the last several years at Mars, and we see methane coming out. The methane is shown on your right side, your left side. The red is intense methane plumes. And we find, after looking over many years, that they're variable. and they vary with season. Now, methane can be produced biotically or abiotically. And what matters next is a mission we call Mars Science Laboratory, which we will launch in November of next year. It's the size of a small car. We will put it down, and it will measure the isotopes of methane, and it will help us determine, at least one step closer, whether Mars is actually harboring life now or not. I want to go to the next wonder, Europa. This is a moon of Jupiter. It's a beautiful moon. When you look at this and you realize that this moon of Jupiter is about the size of our own moon, the first thing you say are, where's the craters? I only see one, maybe two. Europa has resurfaced itself. The gravitational interaction between the planet Jupiter and this moon and the other moons, the other Galilean moons, produces heat in the interior, and it melts the water in this moon. And we now know that underneath the ice crust that's shown here is an ocean, and that this ocean contains more water underneath the crust of Europa than we have water on the surface of this Earth. And this sits in the radiation belts of Jupiter. And those radiation belts really hammer it. But in our models, we now realize that as it dissociates the H2O in the ice, the hydrogen leaves, but the oxygen diffuses through the crust and may be oxygenating the ocean. The astrobiological potential of this moon alone just jumped an order of magnitude. Truly a wonder of the world, and we're planning a mission to 2020 to go to Europa. The next one is Enceladus. This is a fabulously wonderful ice ball moon, very small. It's only about a few hundred kilometers in size, just outside the rings of Saturn. And it has also tidal interactions from the huge planet Saturn. And those tidal interactions are heating, melting the water underneath the surface, and it is coming out in its cracks in huge geysers. And we have flown through this with Cassini. And Cassini continues to monitor these geysers. And indeed, we also find that this moon has about 99.9% water coming out of these cracks in these huge geysers. These geysers go out throughout the system and actually form what we call the E-ring. As you can see in the lower right, that's actually part of a ring that goes around Saturn. It is the E-ring. What matters next is we continue to keep Cassini moving, making observations in this environment so that we can understand this moon and its effect on the system better. Number 6. This moon is also moon of Saturn. It is called Titan, and it is a fabulous moon. It has a rather thick atmosphere, much like ours in the sense of its pressure is about what we call 1 bar down at the surface. But it is far more fascinating than many of the other objects we've studied because it is the only object in the solar system that we have found that has liquid on its surface. It's not liquid water, it's liquid methane and ethane. We find well over 200 lakes already, and we have only just scratched the surface of looking at Titan with our radar. But Titan is even more important than that. This object is huge. It's bigger than Mercury. If we were to pull it away from the gravitational interaction of Saturn and put it in its own orbit around the sun, we would call it a planet. And this planet is much like early Earth with its chemistry and its cycle, its hydrological cycles. It's raining methane right now as we speak in the southern hemisphere of Titan. It is an early Earth. It is a birth Earth, and we need to know more about this fabulous moon. Cassini will do that for us. It will last for another several years and continue on. And now let's talk about the 7th wonder that I chose today. And we'll start by talking about the comets that I mentioned earlier. These are the 4 comets that we have imaged with our spacecraft: Halley, Temple, Boreal, and Wilt 2. And as you can see their sizes, and this is their relative sizes, as they get smaller, they may be more spherical. Perhaps we expected Hartley 2 to be spherical. And as you can see, even though these comets are active, the plumes are hard to see because the comets themselves were so close, we're only imaging the surface. So here is the data from Hartley. This is one of the first images that was sent down. Not all the data is here yet, but this tells us the spacecraft survived. It turned its antenna towards us 30 minutes after it made the encounter, and it took the last 2 hours getting the data back. This comet is unbelievable. It doesn't look like any of the others in many ways. It has these smooth features between these 2 nodules. Some of these nodules are very rough. It is incredibly active. We see material being poured out in every direction. And we were talking about classifying this object with the rest. And perhaps we're missing the point. Perhaps what we're really looking at is an evolution of how these comets live and die as they go around the sun. Now, what matters next is that we have another comet encounter. We're going to go back to Temple 1. We're going to fly by Temple 1 in February 14th, as a matter of fact. And we're going to look at it with a spacecraft called Stardust. And the importance behind that is that comet has already gone around the sun. It's already gone through its maximum sublimation phase, and we will look at it after that has occurred. So we will see the before and after of that evolutionary stage of blasting material, sublimating that material, and pouring it out into the solar system. That will truly be exciting, and that's what matters next. And I want to end with this particular picture. This turns out to be one of my favorites. It's actually Cassini measuring Saturn in the dark. And it took 12 hours to make this. The sun is on the other side of the planet. What's really exciting about this, the light that we receive is reflected off the rings, reflected off the planet, reflected off the rings, and comes back to us. Very dim light, and we've seen it. But the discovery here is right there. If you can see the dot, that is Earth. And we're beaming the data that you're seeing back through the rings to Earth. The small, blue, beautiful, beautiful Earth. And that's what matters next. Thank you very much.